towards this computer. Okay, here we go. So we are looking at our targets for today. So we have 2 targets here, but we have like 4 targets that we've been learning over the last 4 days that we're going to hit on, but these are the 2 most important. So first, given a 2-variable inequality in the graph of that related equation, I can determine which side of the line the solution falls on. This is really, we talked about this in class yesterday, but it was really hit home in your afternoon work yesterday. That video from afternoon work yesterday is probably the most important video I've ever made. I know I said it about every single video, but like literally though, because it is such an important topic, okay? Number 2, I can describe the graph that represents the solution to a linear inequality in 2 variables. When we're talking about, I talked about this in my video, when we are describing a graph of an inequality with 2 variables, there's 2 pieces I need to talk about. First, the kind of line. What were the 2 types of lines that you could have here, Junior?
A dotted line.
A dotted line or a dashed line, good. I don't know if dotted has 2 T's or not, but a dotted or a straight or a solid. Solid is better.
Katie Pepe,
Good.
please call extension 3211.
That is the first piece. The first piece that you talk about when you're talking, nice job, Gabe, about an inequality that you're graphing first. Dotted or solid line. Good. Then what's the other piece that we need to think about and discuss? You talk about the where we are doing what. Shading. Like what we did in our work yesterday, our shading. The shaded region. Okay, if we look back at what we did yesterday, I actually want to pull it up for a second. We talked about I don't remember what slide number, let me pull it up. We talked about, and we moved some pieces of the graph to shade a specific portion of your region. And if we look back classroom, we're gonna go here. Oh, that's not what I want. Okay, give me 3 seconds. I want to look at it. It's kind of important. So we come into our classwork from yesterday, and we look at one of the later slides, one of the afternoon work slides. Task at school. Scroll it down. Open it up. We looked at these inequalities here, and we were shading based on, and when we talk about the shaded region, if we're talking about solutions versus non-solutions, when we shade a region, that means what? That's where the what fall? The solutions fall. So when we were looking at, for example, this slide here from yesterday, slide number 15, what you had to do was you had to test a single solution that falls either on the left side of the line or the right side of the line, above or below. I told you my go-to number to check is 1, 1, because multiplying by 1 is easy, right? So then you plug this 1, 1 in here. You say 1 minus 1 is less than 5. 1 minus 1 is 0 is less than 5. That is a true statement. So that means that point is a what? A solution. And then we said that when we find if the point is a solution, that is the side of the graph that you're going to shade. So you would have taken this piece right here, and you would have put it over that side of the graph. Do you get what I'm saying there when I'm talking about where we're shading? Good. So if we're looking at this guy now here, let's take a look at the first piece of this. If we look at slide number 3, we need to write an inequality based on this story. I'm going to give you 1 minute to look at this story about Fizza, and I want you to write an inequality. I'm going to read it first. Fizza is going shopping online to buy some, I forgot to change it. I said BTS merchandise because she loves BTS. She has $120 that she can spend. She wants to buy 3 rings that cost $11.99 each. She intends to spend the rest of her money on t-shirts that cost $25.50 each. How many t-shirts can Fizza buy? Take 30 seconds right now to write an inequality. Kyle's going to share it out once he gets it? People at home, I want you to throw your answers in the chat. What is the inequality that goes along with Fiz's shopping spree? Because that's what it is, it's a shopping spree. Nice job. Think about the symbol that you're going to use. Think about in the context of the story, would it be or equal to or not? Okay. So Kyle, here we go. Kyle, can you help me out with this inequality here?
120 is greater than or equal to 2550
Plus 1195 times 3. Good. What do we think? Can I simplify this? Can I simplify this inequality? Connor, what do you think? Perfect. You could simplify it by multiplying 1195 times 3. Very good. 1195. 35. So 120 equal to 25.5x plus, how much was it? 35 point what? 35.85. 35.85. Good. Very good. So you can write it like this guy up here. If we want to be more specific, more succinct, more simple, simplified, we could write it as the second guy here. Boom. So now we need to find the solution set to this inequality. And what would we have to do here first, before we talk about what the solution set's going to be? What do we have to do here? Kyle? Okay, so first, let me scooch it over. You can do it in this box over here, work for solving your inequality. So you would take this 120 is greater than or equal to 25.5x plus 35.85. And we would have to first subtract 35.85 from each side. Nice job, Kyle. And then what would we get? 120 minus 35.85? 84.50? 15. Very good. 35.85 is greater than or equal to 25.50x. What's my next move to find out how many we're doing here? John, how would I get that x by itself? Nice job. Very good. Divide by 25.5. Divide by 25.5. So when you divide by 25.5, what's the value that you're going to get? Kyle. 3.3. And it would be is greater than or equal to x, right? Good. How would we write, if we're talking about, we're taking this in context though. So what would the solution to my system, what would the solution set to this system be, or this inequality be? The solution set, would it be 3.3? 3, very good. And why did you say 3? Very, very, very good. Nice job there, Gabe. And then we want to take it one step further and say, in the context of this story, Fizz cannot buy a third of a t-shirt, or like 0.3 3/10 of a t-shirt. You have to round it down to 3. Good, nice job. Boom. Fantastic. Now we're going to look at the next piece where we are going to be going on Edulastic and we are going to be graphing some inequalities. So let me, I'm going to keep this up for another 10 seconds. And then I'm going to erase. Here we go. Okay, let me scooch her over. And then we're not going to answer that other question over there because we're going to do some things with this here. So now we're going to go to edge elastic and we're going to graph four inequalities. But I don't want you to get started with them yet. I want to look at them first and then I'm going to give you time independently to do each. So you click on your link, takes you to edge elastic. Did it take you guys directly to the assignment?
Yeah.
Perfect. Okay. So mine looks a little bit different because I'm in teacher mode. You as a student? We're here, okay? So it says graph this inequality. Be sure to choose the appropriate line type and shade the appropriate region of the grid. So here we go. First thing I want you to do is when you have to graph an inequality, I want you to rewrite it, taking out the symbol, because we're gonna do something with the symbol at the end. I want you to rewrite it as just an equation and put an equal sign in. So like, for example, you would rewrite this as y is equal to negative 3x plus 4, okay? So we're gonna have to now graph that line. So if you go into edge elastic, and we know how to graph things in edge elastic, how would I go about graphing this equation? How do you graph an equation in general and then also apply it to how we've done it in edge elastic? You'd make sure that your point button is clicked. And then where would you start when you want to graph this? Very good. The y-intercept, which Abby says is 4. Very good. So on your y-axis, you're going to come and you're going to put a point at 4. Good. Boom. Now, I need to continue this line. If I look at that slope, and I want to write it as a rise over run fraction, it would be what over what? Connor? Very good. Very good. You're going down 3 and to the right 1 because we're always moving to the right. So the negative is going to be applied to, are you going up or down? Good. Nice job. So I'm going to go down 3, 1, 2, 3. Over to the right 1 and put my point. Now in edge elastic, how do I create the line with that, John? What? You click so you go to the line, you click on the 2 points. Very good, John. Now I need to decide, is this a dashed line or a solid line? Where do I have to look to determine whether or not it's a dashed line or a solid line? Where do you have to look in the inequality to determine the type of line that we're putting here, John, or Junior? The symbol. So then what is that symbol, that inequality symbol tell you? Or equal to is dashed? It's not going to be dashed because we have that or equal to, and I like to think of it as like, if it has a solid line under it, that's going to be a solid line. If there's no little line underneath, it's going to have to be dashed. Just like the line underneath it, it's going to be a solid line. Good, so you don't even have to click on that dash button because we know that it's not going to be dashed, okay? So now I need to determine, am I shading on, well, it's really, you can think of it 2 ways. Is it above or below, or like to the right or to the left? So what do we do to determine where we shade here, Kyle? Pick, what do we think? How do we decide where we shade? We pick a point anywhere, really. You can pick any point. My suggestion is don't pick a point that falls on the line though, because if you can tell if it's going to fall on the line by the symbol, right? So I would pick something somewhere clearly either above or somewhere clearly below. Okay. I usually go with 2 points. I usually go with 1, 1, or I like to go with 0, 0. What were you thinking, Connor? Which one did you choose? 3, 1. Okay. So he said he wants to do over 3 up 1. Good. Okay. So then we're going to take that point and we're going to plug it into the inequality. Let me just erase this symbol here. We're going to say 3, or y, which is 1 in this case. 1 is greater than or equal to negative 3 times 3 plus 4. Negative 3 times 3 is negative 9 plus 4 is less than or equal to 1. 1 is greater than or equal to what number? Negative 5. Is that a true statement?
Yes.
Yes. So where are you going to shade? To the right, because you want to shade, if it's a point, you want to shade the region that's covering it. If it's not a point, you plug it in, it's not a point, you're going to shade the opposite side of the line. So you're going to come to, if you wanted to change the type of line, you would hit dash, but you're not going to click that. And then for the area, you click area to shade. So you're going to click area and then click on that half of the grid there. Boom, Kyle, or Connor. Okay, so maybe try closing it back out. Or if you just want to watch along, like if it's, because I'm not going to grade this, I'm going to grade it as a whole. So if you don't get this, it's fine. I just really want to sort of show you guys how it works. Okay, so we did that one together. So now I want us to look at the next one. Okay, so I'm looking at number 2. What do we notice about number 2 here? Anything at all? What do we notice about number 2 here? You can see on yours as well. It's kind of small up here. It's not loading? Maybe.
That's the first problem.
Is that working for you, John? Okay, perfect. Okay, so what do we notice here? Abby said it's not y equals. It's in what form? What do we call that? Standard form. Standard form. When our y and our x variables are on the same, nice job, Dave. When our y and our x variables are on the same side, we call that standard form. Good. Very good. So we have our standard form equation. How do we graph standard form equations? There's 2 ways that we can do it. What are the 2 ways that you graph a standard form equation? You can convert it to a y equals, right? We can convert it to y equals, or we can find our intercepts and plot those intercepts to connect. If you look at these guys, this equation here, what do we notice about these numbers? Maybe the numbers on the left side as compared to the right side. Kyle? Okay. What else, Connor? They're multiples, right? So these numbers over here on the left easily like go into that 15. So you have 2 options for when you graph this guy. Number 1, you can convert it to y equals form. That's always going to get you there. It's going to sometimes have fractions though, and it might be a little funky donkey, but it'll get you there. We can also do intercepts. That's the way that I want to try it today. Okay. So I'm going to rewrite this equation or this inequality as an equation. 5x minus 3y is equal to negative 15. And I'm going to calculate my y-intercept and my x-intercept. Y-intercept, x-intercept. Intercepts, when we're calculating intercepts, I say that is usually counterintuitive, right? So that means I'm going to plug 0 in for which letter? For the y-intercept. Plug 0 in for x. Very good. So if I say 5, and then I'm going to plug 0 in for x, 5 times 0 minus 3y is equal to negative 15. 5 times 0 cancels out. We're left with negative 3y is equal to negative 15. Y is going to be equal to how much? 5. Good. So my y-intercept is going to be 5. I want you to take 30 seconds right now to calculate your x-intercept. Plugging 0 in for y. Very good. Go ahead. Nice job, guys. What are we going to get for a x-intercept here? John, can you help me out with this one?
3.
Oh, okay, a -3. So you would, the 3 times 0 would cancel out. We have a 5x is equal to -15. Divide by 5, divide by 5. X is going to be -3. So, oh. Okay, so we have our y-intercept, our x-intercept. Now we need to do what with those 2 points? Graph it or plot them, right? So on my y-intercept, I'm going to put a point at 5. I'm going to put an x-intercept on my x-axis at where? The -3. And then I need to do what with those 2 points? Connect them. Hit the line button, click your 2 points. Boom. What do we think about this line here? What do you think? It has to be dashed because it's not or equal to. So to do the dash, I'm going to show you this. You're going to do the second 2 independently. So just be aware of that. Dashed, and then you click the line. Sometimes you might have to like double click it. It's a little bit finicky sometimes, but it works. If you dash it and you don't want to do that, hit the undo button, and you might have to replot the line, like replot the line, and then dash it. Try it again. Come on. There we go. See, I just had to click it like 3 times. Now I need to figure out where I'm shading. So, what is the point you might want to plug in here, Connor? Boom. So I'm going to take that point to test. Am I shading below or above the line? Okay, so you can just follow along, Peyton. It's not a big deal. Okay, so I'm going to take my 1, 1. I'm going to plug it into my inequality. 5 times 1 minus 3 times 1 is less than -15. 5 times 1 is 5, minus 3 is less than 15, -15. 5 minus 3 is 2, is less than -15. What does this inequality, is this a true statement, John, or a false statement? False statement. So where am I going to shade? The opposite side of the graph, because this point is not a solution. So this region is not going to be shaded. We're going to shade on the opposite side. So you're going to hit your area button and you click it. Boom. Okay. Let me know if you're having trouble with that in the chat. Okay. Okay. Awesome. So now you're doing the next 2 are going to be independent. I'm giving you 5 minutes right now to work on 3 and 4. Making sure that when you see a convert it to an equation, graph it, and then talk about the type of line and then which part are you going to shade. Take 2 minutes right now. People at home / at school, please let me know if I'm going, like I know I'm going, like I feel like I need to go slow, but if you guys are super understanding this, tell me if I need to speed up a little bit, okay? Say, give us more independence. I really wanted to do the standard form one though together. Think about what kind of line these are going to have. We're more than halfway there. You should. These are easy ones to graph, guys. Easy ones to graph. Turn it into an equation. Like take out the symbol, turn it into an equation, and graph it. If you have a single variable, it's either going to be a vertical line or a horizontal line. This is review. This is review. take another 27. Let's go. No excuse why this isn't done. Okay, here we go. Okay, first step, rewrite it as an equation. Take out the symbol, write it as an equation so that we can graph the line. Can I graph that looking at it right there? Looking at this negative 2y is equal to 8, can I graph that? No. What do I have to do? Connor. Very good. Divide by negative 2. Divide by negative 2. So y is going to be equal to negative 4. Okay, so I'm going to have what type of line, which axis is it going to hit, first of all? The y-axis. So it's going to be horizontal or vertical? Horizontal. So here is the dealio with this. You are going to hit the point button. We're going to hit the point button. We're going to come down and we're going to put it a horizontal line at negative 4, right? So I would just hit like my y-axis and then like any other point on that line of negative 4, and then connect them using that line tool feature. Boom. I have to just scroll a little bit. Boom, boom. I have my line now. What is the next piece I need to think about when I'm graphing this dude? What do you think, Ken? Gash? Why do you think it's going to be dashed? Very good. Because there's no solid line underneath, it's not going to be a solid line. Very good. So I have to dash this dude. I hit my dash button. I scroll it down a little bit so I can tap it. Tap it. You might need to tap it twice if it doesn't hit the first time. And now we need to think about our what? So what? Our area that we're going to be shading, right? So where are our solutions going to fall? So I have to take my inequality. What's the point that you want to plug in there? 1, 1. Okay, perfect. Listen, guys, 1, 1 is always a good go-to number. So I'm going to say negative 2y is greater than 8, right? And then I'm going to plug in my 1, 1. Do I have an x to plug in here? No, so I'm just going to plug that y value in. So I'm going to say negative 2 times 1, which is going to fall here, is greater than 8. Negative 2 minus 1, or times 1, sorry, is negative 2 is greater than 8. Is that a true statement? No, it's a false statement. So where are we going to have to like shade this guy? Below the line. And here's the deal is I think this idea of saying below or above is good, but I think sometimes when we have slanted lines, saying below or above can sometimes be a little bit tricky. Like if it's a really steep line, like is there really a below? Is there really above? So I want you to think about the way that you describe that and making sure you're clicking the right region, okay? Now let's look at the next one that we did. Wait, does everybody at home sort of, so you might have to like, so Sadie, sometimes you have to like click it a few times for it to work. And then if it still's not working, like click on the shade, like the shade part, and then go back to the dash and try it again. Oh, wonderful. Oh, for tomorrow? Yeah. Perfect. That makes sense. Really? No problem. You know what? It's not a big deal. So if, like I said, these are not getting graded for accuracy. These are just like a little practice sort of assignment we're doing together. Really practicing with how to do it on as a lesson. Kyle, question. Or go ahead. No, go ahead. Negative 4x, remember we write it as an equation, equals negative 24. What am I going to get here? What do I have to do? Divide by negative 4, divide by negative 4. X is going to be equal to 6. Okay? So that means, what kind of line am I going to have here? Y. because it has to hit our x-axis at that number 6. Good. So it's going to be a vertical line. Hit that point button. Boom. Hit the. You can really hit any points along here. I just like to hit the x-axis and then like a point. And then you connect them using your line tool by clicking those 2 points. And then what kind of line are we going to have here? Junior,
Yeah,
why?
because there's not a solid line under the symbol.
Very good. Because it's not or equal to, we're not going to have it be a solid line. So you hit that dash button. Sadie, let me know if it works this time. You hit the dash button. You click the line. If it doesn't work, maybe try clicking the area and then the dash again. Try clicking a couple times. Mine is a little bit weird because I'm on the smart board. I did it. Sadie, did you get it to work, my friend? Still no? Okay, well, I might have to troubleshoot it. Why don't you try refreshing the page and trying it that way, okay? Oh, yes, Naseem, I'm sorry about that. Go ahead. That must have lagged because I didn't see that. Now we're talking about what? Where did we shade here? Kyle. Shade on the right, because when you plug 1, 1 in, you would say -1 times or -4 times 1 is greater than -24. -4 is greater than -24. That is a true statement. So we would shade on the left-hand side. Very good. Boom. Okay. If it doesn't work, Sadie, that's okay, as long as you see how I'm doing it and I can troubleshoot it today. Okay. There we go. We just graphed 4 inequalities. Awesome job, guys. Awesome. Just an FYI, if you check your answers like the last 2, I didn't change the answer key, so it might say it's wrong. They're not wrong. I just was too lazy to do it that way. And if you want to submit it, you can submit it. So it's no longer in your like needs to be finished assignments. And then we're gonna go back to the slideshow. Okay. So now on slide number 5, I'm giving you 2 minutes right now to look at each one of these inequalities here and decide, are these points solutions, yes or no? You're taking 2 minutes right now to test all of these for whether or not they are solutions to each one respectively. You don't need to look at the grade when you submit it because like I said, I didn't change the answer key. So 2 of them are wrong. You might need a calculator for this one, guys. Once you get an answer for the first ones, let me know. Taking another 23, guys. You're doing great. Okay, everybody in the chat, let me know for the first set. Are they solutions? Is 1, -1, comma 1 a solution to the first one? What do we think? What do we get? Nice job. Thank you, Gwen, Peyton, and Max. Yes, this is a solution. Good. And how did you know if the point was a solution or not? Kyle? Plug it in and then look at the inequality. Is it a true statement? Is it a false statement? Good. What about -1, 1 for number 2? Very good. Nice job, Kyle. Yes, this one is also a solution. Very good. Perfect. Nice job, Gwen. Awesome job, Peyton. Love it. Now, let's look at 2. For the first inequality, was 1, -2 a solution? John says yes. Any confirmation? Triple confirm. Gwen says yes. So does Gabe. Yes, very good. This one was a solution. Very good. Now, Gabe is saying for number 2, it is not a solution. Confirm or deny? Disagree? Okay, let's plug it in and let's solve. So we're going to say x is 1 minus -2 is greater than 3
Mr. Hasbin,
plus
you could call it
positive
214.
plus positive, right? Because it's minus a negative. And then so 1 plus 2 is 3 is less than 3. Is that a true statement? Why not? Or if the equal to line was underneath it, it would have worked. But because the equal to line wasn't there, not going to work. Good. Wanted to test it, wanted to prove it. Good. Now we're looking at 4, 0 for number 1. Is it a solution? Abby Wasta and Peyton are both saying yes. What are we thinking? John?
For 2, it's yes.
So 2 it's for yes. Good. 10.
I mean, for number 2.
Okay.
No.
So here, 1, yes.
No.
Okay, so we're looking at number 3.
I had the right thing.
Oh, okay. Kyle, help me out. No. Very good. Very good. Nice job. My friends at home, very good. What about number 2? No, it's not a solution for either of them. Good. And Gabe confirmed. Last one here, 2, 0. For number 1, it was a solution. What do we think about for number 2? Yes, very good. Very, very, very nice. Very good job, guys. The way that we test if a point is a solution is by plugging it in and simplifying it and determining is the inequality true or false. If it's false, it is not a solution. If it is true, it is a solution. Next piece here, we are graphing inequalities. So this is what I want you to do here. I want you to, I didn't put text boxes in, I'm a stinker. So what you need to do for the first one is you need to use these dots and lines up top here to graph this inequality, number 8 and number 18 on here. So grab them and put them underneath the line because there's not really room above. And then for this one down here, you're going to have to put a final box for your answer. I forgot to put a text box. So I want you to take 2 minutes right now to graph these 2 inequalities and then solve these 2 inequalities. Nice job. Let's take those 2 minutes. Let's go. Think about the type of point you're going to use. Think about the kind of arrow you're going to use in the direction. Well, really, it's just the direction. Okay, let's take a look. We have 30 more seconds. You're doing great. Graphing the 2 at the top and solving the 2 at the bottom. They are a little bit challenging, so beware. Kyle, what are you thinking?
First, that's what we go on second. The second.
What do you mean? What's on? What's up?
Can't go back.
Oh, okay. So, what you want to do is you want to write it on the picture. That's definitely the order. And you will send that. And then that. Boom. Hey, here we go. Oh, let me see. Hi, this is Mr. Main. Hi. I am currently teaching. Can I call you back in a little bit? Like, can I call you back in like 20 minutes, like 10 minutes? Okay, yep. Sorry. That was Miss Albert. Okay, we're graphing these guys. Woo! I love graphing inequalities. They're so much fun. Okay, I'm graphing this first one here. I'm looking at it. It's a negative y is greater than 2.5. So, question, first of all, can we graph this the way that it's looking? Yes, very good. Okay. So what kind of dot are we using here? An open dot. And why do you say open? Because the symbol does not have the line under it. Very good. Very good job, Kyle. Let me just make this full screen. Sorry, guys. Okay. So we're saying we're going to put a open dot because it is not or equal to. Very good. Okay. So I'm actually just going to draw my dots on here. And where are you drawing a dot here? I have a question for you. If I look at my y here, because this is a one variable guy here. This is a one variable inequality now. What? Go ahead, Connor.
It's a negative y.
Okay.
So, and it is greater than positive numbers.
Okay.
So you have to send the line backwards, the other negative. Two negatives are positive.
Very good. And if we want to think about it that way, we can think about it that way. We can also say we want to have a positive y. So the way that we do that is divide by negative 1 on each side to get it to be a positive y. Divide by negative 1. Negative 2.5 is going to be, which direction is my symbol going to go now? Which way? Like, or is it gonna, what's gonna happen to it? It's gonna flip because we divided by a negative number. We want to get it so that it's a single positive variable. So we have to do some work before we can even start to graph this by dividing by 1 and negative 1 and flipping our symbol. So we're still going to use that open symbol, but where are we going to place it on our grid? Kyle? The negative 2.5. And your y is going to be less than negative 2.5. So which direction is it going to go? To the left or to the right? It's less than, so it's going to go to the left. Very good, Kyle. And Junior, very good. Does everyone see why this one was a trickster? I picked this one specifically. I was looking at it, I was like, my evil witch voice.
My line is just weird.
And that's okay. And it doesn't, I mean, I'm not looking for like super straight. I'm looking for general same dots and general correct direction. So now 18 was significantly easier. What are we doing to graph 16 or 18? What do I have to do to it? Huh? Nothing. And what kind of dot are we going to use for this guy? A closed dot at what number? Here we go. Let me share my screen again. Sorry, guys. I personally love when that happens. Am I sharing the right screen? Did I click the right one?
So you see, like, you know how you share your screen and it shows like the green bar where you have that menu?
Yeah, but so you can move it from screen to screen. Like I could go like this and I could move it here. So that's the only reason I'm asking. Okay, good. So
When you choose the screen you want to share, automatically goes to that screen.
okay, perfect. Okay, so I have my point at 1. Sorry guys about that. We are good now. Which direction is my line going to be going? To the left or to the right? Very good.
Iowa Creek, please call extension 3211.
So our line is going to be going to the right because our p-values are going to be greater than that 1. Very good. Now, 4, 5. I love this one. This one's kind of terrible. We have to do a lot of work here. So, what do we have to do first when we're looking at this guy? Kyle?
First, you have to make it into equal symbol.
Okay, you can make it, you can turn it into an equal symbol. Okay, so you could say 6 parentheses 4 minus 3r close parentheses is equal to 5r minus 137. Okay, and then I have to do what?
Distribute.
Distribute. Very good. 6 times 4 is 24. 6 times negative 3 is negative 18r is equal to 5r minus 137. Now, what do I got to do here? Kyle?
Minus 24 to each side.
Okay, you could move your constants first by minusing 24. Very good.
I did it a different way.
Did you move your r's first?
No, I added 137 to each side.
Okay.
And then I added 18 R to each side after that.
Perfect.
So,
And both of those are going to get you in the end the same value. It's just about maintaining equity. And this way maintains equity. Good. So Kyle likes to move his constants first. Good. So then when you subtracted here, you got negative 18r is equal to what?
I did the exact opposite he did.
Okay. So Kyle, what would be my next move here? What am I'm left is 5r and minus what?
Oh,
Yeah.
minus 161.
Minus 161. Good. Now, I need to get my variables, my r's to one side. What am I doing to each side here, Kyle?
Subtract 5r.
Very good. Okay, I'm going to come up here. Okay, so I'm going to have negative 18 plus 5 is 19, 20, 21, 22, 23. Negative 23r is equal to negative 161 divided by negative 23 divided by negative 23. R is equal to,
7.
what was it?
7.
7. Very good. Okay, so I got an R is equal to 7. So now, because I did some stuff with some negatives, now I need to figure out which direction I'm moving. And you can't go back to the original inequality to just say like, oh, it's going to be going this way. We have to test a point to figure out which way. So I'm putting my point at 7. I'm going to put my open dot at 7. And then how do I test out which direction I'm moving here, Kyle? I could take like 0 and plug it in and see what we get. Like to the inequality, we could say to ourselves, oh God, okay, 6, 4 minus 3 times 0, close parentheses, is greater than 5 times 0 minus 137. Okay, you plug that 0 into that inequality. We would say 24 is greater than, because that cancels out, 24 is greater than negative 137. Is that a true statement?
Wait, no, 24 is less than.
Oh, less than, you're right, less than 137. Is that true?
No.
No. So that means 0 is not going to be a solution. So which direction is my line going to go here? Very good, to the right, very good. Let me erase and I'm going to draw that in again because I have a lot of stuff there. We have our 7 and it's going to the right. Huh? Good.
Or they just disappear.
I don't know. So So then if we look at 10, what can we do with 10? What do we have to do with 10 first, John?
You have to, well, I added the 2 and 5 together.
Boom. So you would say negative 154 is greater than, what's 2n plus 5n?
7.
7n. Okay? And then do I even have to turn this into an equal sign? Or can I just solve this inequality? I can just solve it because why do that and then have to plug one in and test if I know I'm not going to be dividing by a negative number? So then how do I get my n by itself? Divide by 7, divide by 7. N is going to be greater than how much? Kyle?
22.
22. What was it? Negative 22. Very good. Negative 22 is greater than n. If I want to plot this on this line, what kind of point am I using? Open at negative 22. And then if negative 22 is greater than my n values, which direction is my line going to be going? To the left. Very good. Because that means all of our other values are going to be smaller. Our n values are going to be smaller than negative 22, which is this region right here. Nice job there, Gabe. Fantastic. Let me tell you what you're doing today. Okay, so now you can hit submit for yourself, and then we can close it out. And let's look back at our slides, okay? So what I want to do a little bit of work with today, instead of looking at 5, 6, and 7, I want to jump right down to 8. Okay, we're going to come back to those ones when we have a little bit of time and tomorrow, but I want to look at 8 first, okay? When we look at slide number 8, bless you, it says, for each graph, write an inequality whose solutions are represented by the shaded part of the graph. So we need to create an inequality for this graph here. This is scary. This is a little bit scary. So which one of these, A, B, C, or D, when you look at it, do you think is going to be easiest to write an inequality for? No wrong answers. Aiden, what are you thinking?
D,
Why?
because there's only one intersect point across it.
Good. So we know that it's either going to be like X is equal to or Y is equal to. Good point there, Aiden. Good point. Okay, so if we look at D, what is our variable going to be for this equation?
Y,
Why do you say that?
because that's where the line hits.
It hits our y-axis. Very good. Nice job, Haley. That's a good point. It hits our y-axis, so we're going to write it as y is equal to. Good. So it's going to be y is equal, or so y, right? And then we're going to have to put some sort of symbol in there. I don't know which one yet. Do we want to think about which symbol we're going to put in there? What do we think? Or let's put the number first. So we're going to say we're going to compare y to what number? What number is it hitting at, Aiden?
-4.
-4. Okay, so we're going to be comparing y to -4. So now we need to think about, logically, these numbers that we're hitting here, are they bigger than -4 or less than -4? Claire?
Bigger than, and it can't be equal to because it's a dashed line.
Good. So which of these pieces or which of the sides is going to get eaten by the alligator? The y or the -4? Why do you say that?
Because the y has to be greater than -4 to keep going up.
Very good. So we're going to be able to say y is, and then we're going to put the alligator mouth opening towards the y. So it's greater than, and are we going to underline it, like use the underline tool, or are we going to leave it the way it is? Why, Haley?
Because there's no line in between for equal to.
Yep, and there's this a dashed line. Because it's a dashed line, there's going to be no or equal to. Good. Very, very good. I know that was kind of a little bit weird. We're going to be doing a lot more practice with this, like this piece, like a lot, because I think this is probably the most challenging bit of what we've done so far. So now we did D. What's another one that looks pretty easy to solve or write an inequality for? C? Okay. And if we need to write an equation for C, this one's probably a little bit more challenging because like it's hard to see, you can't see the axes numbers, but you can see these coordinate points here. So what is it going to, we're going to be comparing which variable?
X,
Why do you say that?
because that's where the line hits the X.
It hits the x-axis. Good. So we're going to be comparing x to what number? Where is it hitting our x-axis? What is our x value in those coordinates? Claire? -5. So we're going to be comparing x to -5. So, Fizza, if you're looking at the portion that is shaded here, what are those values as we compare them to -5? Are they bigger than -5 or smaller than -5? They're bigger, right? So which symbol are we going to use here? Greater than or less than? Greater than. So my alligator mouth is going to eat who? Jessica. Which my alligator is going to eat the x or the -5? Based on this inequality or this graph here. But we said that the x values, the shaded region, is bigger than that -5. All of these values are bigger than. So it's going to eat the x. And if we're thinking about, is it going to be or equal to or not, what are we thinking? Dillo.
It's gonna be equal to because there's not dotted line.
Very good. It's a solid line. It's not dotted. So we're going to have to highlight him and underline him. Boom. Okay. Now that leaves us with A and B. Darn it. Okay. So I have the equation. I have this graph here. What are some pieces of information that I can pull from any graph? Whether it's an inequality, whether it's a equation line. I can look at it and I can calculate what value. Aiden. The x and the y axis, like the intercepts, right? Good. I can calculate my y-intercept, right? So if we know that we can write equations in the form y equals mx plus b, I know what my b is for b here. What's my b going to be? What's my y-intercept? If you can't see, look on your computers. Or, yeah. What's my y-intercept going to be? What are we thinking? Where does it hit my y-axis for letter B? 4. It hits at 4. Good. So my intercept is going to be +4. Okay, we're going to be comparing y to the other half. So then now I need to calculate my slope of this line. Oh, this is easy. How do you calculate slope? Draw in a slope triangle. Slope triangle. Slope triangle. I'm going to draw a slope triangle. Ba-doop. Wait, let's see. It doesn't hit perfectly though. So we got to find a spot where it hits perfectly. It hits perfectly. Oh goodness, that's not what I wanted. It hits perfectly here and here. So it has a rise of, trickster, don't get tricked. How much is it going? What direction is it going? What direction is it going, Jessica? Up or down?
Wait.
Look at the line. It's going where? What kind of slope does it have?
Oh, I was saying yes.
What kind of slope?
I'm so.
Alright. Pause. Pause, please. Pause, please. We're starting again. I have this equation line here. Is it easier to write an equation in standard form or y equals mx plus b form? Have I ever taught you how to write an equation in standard form? Default answer, y equals mx plus b. Slope and y-intercept. So I need to calculate my slope and my y-intercept to write this equation. Okay? I'm going to be comparing, and I write it as y equals mx plus b. We said our b was 4 plus 4. I need to calculate my slope. Okay? The way that we calculate a slope from a graph is by doing what? Aiden?
I don't know, it's calling the words where you go over to the y-intercept and see how many it goes up from you.
Good, that's the slope. We draw a slope triangle in, right? We draw a slope triangle from where they meet 4 boxes perfectly. Like I said, from here down and over 1. So what is the rise of this box? Do not get tricked by that idea of rise. Rise is a general term here. Claire? -3. The rise is -3 because we're going in what direction? Down. Yes, 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 and yes. Very good. I appreciate myself because I went back and we started over. Talk to myself. So we went down -3. My rise is -3. What is my run here? Dillo. 1. Yes. Very good. So I have a rise of -3, a run of 1. If I write that as a slope, what would it be? -3, very good. Or if you want to, you could write it as -3 over 1x. Okay, so we wrote it as an equation. Now, we need to convert it because it's shaded into an inequality. Okay? So, we need to think to ourselves, the values, the y values, right? Are they larger? The solutions, are they larger or less than those x values? Are we shading above the line or below the line? In theory. It's like slanted, but Claire? Above. It's getting larger, right? We're shading above it. So it's going to be, we're going to switch this equal sign out for a y is what as compared to my x values? Greater than or equal to. So good, Claire. And why did you say or equal to?
Because it has a solid line.
Because it has a solid line. Good. Awesome, awesome, awesome work. Okay, we're going to look at one more. Okay, this is an important question. I'm looking at this guy here. What form do you feel more comfortable writing this equation in? Standard?
Good afternoon, and please listen carefully as I announce buses. Red, purple, and gold team walkers and pickups, please report to the front of the building for dismissal. Also routes 18, 19, 20, 21, and 20.